What's the importance of this pinch point in manufacturing?
Okay, if you look at it before, if you can imagine if that bot was around a lot of human workers, their fingers could get in there and get caught. So
Mhm.
so it's an injury hazard. It's also something that just gets snagged on something in general. So you want to have something that's much easier when it goes around different things, doesn't get caught on it. There's a reason
Mhm.
why people do not wear ties on the shop floor because your tie gets caught in a piece of equipment, you're strangled right away, right? So
Yeah,
there's a lot of things like that. And if you do wear a tie, make sure it's a clip on.
we're here today with Scott Walter, going ballistic 5 on X, at
Yeah.
Visual Components, robotics expert. Also, we have Larry Goldberg, serial entrepreneur, software magnate, also has owned some manufacturing businesses. Um, and we got Matt Smith here for the nerdy financials. We want to talk about TeslaBot, the video we saw last night. Also want to talk about some questions Matt Smith and I have about TeslaBot. So I want to get started with just overall impressions from the video last night. Scott is in Switzerland. He's on the move, so we may not see him the whole time, but that's okay. Uh, we'll have him in more than spirit. So Scott, what did you think about the video?
I was, really blown away by it and really happy to see that they implemented a lot of the improvements I was hoping they would do. Now, I don't think they did the improvements because I told them they should do the improvements. I think they did the improvements because it was the logical next step to do, and that they had got so much data from the first round, they knew exactly where the optimization needed to be. So first of all, I mean, the most obvious thing was you didn't see any cables hanging out anywhere. Like you were always wondering before, what are they going to do about all the cables?
Mhm.
Well, they cleaned that up, and they cleaned it up because it's part of the actual actuator design. They even said in there that the cabling and the sensors are now kind of part of the actuators, or actually the term they use was the harnesses that were going through there. It, the cables are definitely lighter and tighter, or sorry, the actuators are lighter and tighter, which is why the shoulder doesn't look as bulky as it was before, and it was so easy to kind of cover up and all. So right now, the robot looks like it's ready to go, let's say, to be used in a production environment because it doesn't have the pinch points anymore like it used to have. It
Mhm.
doesn't look as threatening. And, just huge improvements on the aesthetics and overall and the kinematics. And of course, we can talk about the hands, we can talk about the feet. There's a lot of stuff. And I think one observation that I kind of made towards the end is you notice the Tesla logo was actually on the bot this time. The other two versions, they didn't bother putting the logo on there because they knew that was not the final form. And now that they're getting closer to, let's say, the final version, they've decided to start doing some branding.
Uh-huh. Let's geek out a little bit and then we'll go to Larry with his thoughts. What's the importance of this pinch point in manufacturing?
Okay, if you look at it before, if you can imagine if that bot was around a lot of human workers, their fingers could get in there and get caught. So
Mhm.
so it's an injury hazard. It's also something that just gets snagged on something in general. So you want to have something that's much easier when it goes around different things, doesn't get caught on it. There's a reason
Mhm.
why people do not wear ties on the shop floor because your tie gets caught in a piece of equipment, you're strangled right away, right? So
Yeah.
there's a lot of things like that. And if you do wear a tie, make sure it's a clip on. Um, and so that's one reason. And the other is you notice the robot's just softer all around there. There's no hard edges anymore. So again, if it was to fall over on top of someone, they may have been injured because you would have had the sharper edges, but now it's far more blunt in many places and not so bad. So overall, I would be more comfortable having that version of the Tesla bot working side by side with
Mhm.
another worker.
Larry, I'm curious your thoughts about the video, what we learned, what stood out for you.
Well, the for me, the handling of the egg seemed quite amazing. The delicacy of the touch.
Mhm.
I wasn't ready for that. Everything Scott said about cleaning it up and so on. Of course, it's a 48-volt system, so they get a lot of power for very little wiring, and so that is really good. Um, but I was really surprised at the delicacy of the touch, which I think is going to be quite important for, complex manufacturing, particularly of electronic components, because that's not something one had given thought to about a bot doing. I mean, many electronics are manufactured, en masse, by industrial machines, but you see rows and rows and rows and rows of people assembling, say, iPhones in China. Why? Because ultimately that final, some of that final assembly has to be done by hand. If the bot can conquer that, that would be amazing. I mean, I could see us bringing manufacturing of phones, reshoring that. That would be an incredible win. What about that, Scott?
Yeah, well, the one thing I want to say is that the handling of the eggs was literally an Easter egg. Okay.
Yeah.
And the reason it is that in robotics, it's always been a problem of trying to develop a gripper that won't break an egg, that can pick up, something heavy and solid, and also
Right.
delicate enough to be able to pick up an egg without breaking it. So anyone that knows anything about gripper designs and the history of robotics, and they see that, they go, "Oh, wow, it's there. They've really got the gripper that has that delicate touch." Now, to do that, they decided to add in tactile sensors, which we were debating whether they would ever do that. I thought, they may not have to, but they've discovered that they need to get that additional dexterity, and to do something like Elon says, it will be able to thread a needle, which will be amazing. I mean, that's a pretty delicate task. But the most important thing is, if you look at it, those tactile sensors aren't just to say, "Hey, I'm in contact with something, I'm not in contact with something." It actually is a pressure sensor that's telling how much contact you are having and where you're having it on there. Because if you'll notice where those hot spots are on there, they move around a little bit. And what this means is, I think these sensors are sensitive enough that it could read Braille.
Wow.
Or, as
Nice.
James Dalmas said, maybe count the change in your pocket. I'm not sure I would go that far, but I have a feeling it probably would be able to, tell kind of the roughness of a surface and literally be able to say, yes, it could read Braille.
But would you, Scott, would you go as far as say they could assemble electronic components like an iPhone?
Oh, yeah. Yeah,
Because
absolutely.
because
Absolutely. If you could,
when you think about the win there, it is just staggering.
Yeah,
yes.
that'd be huge.
The economic implications of reshoring that kind of manufacturing is truly staggering.
Yes, it is. It is. And it's not just cell phones, but you could think of a whole
Right.
variety of
Right.
industries where are just light manufacturing that you would like to have done.
Are you a Teslanaire eager to further grow your Tesla shares? At Rebellionaire.com, Bradford Ferguson and Matt Smith have demonstrated their aptitude, consistently delivering groundbreaking, world-first research featured on platforms like Tesla Daily, Dave Lee on Investing, Solving the Money Problem, Limiting Factor, and Farzad Misbahi. At Rebellionaire.com, we go beyond just holding shares. We strategically trim and add, capitalizing on the stock market's emotional fluctuations. Our approach involves selecting additional exponential growers like NVIDIA, which we believe are undervalued by Wall Street. We use covered calls to create cash flow from stocks, even those without dividends. Our financial planners craft a personalized master plan using a first principles approach, addressing all aspects of your finances, not just your investments. Our goal is to consistently increase your share count, avoiding missed opportunities during market FOMO or panic selling, and minimizing tax liabilities. If you're ready to enhance your share growth with our help, visit Rebellionaire.com.
John, I'm curious, do you think with the design that they have on the hardware, could they get to the point where it could crack that egg and put it into a bowl? I mean, that's a whole other problem. And then you've got some potential residue on your bot's fingers that would need to be cleaned up somehow. So that's certainly less economically useful, I think, at least in the short term, than what Larry's talking about. But just as a capability, how far away do you think we are from being able to handle that incredibly dexterous task?
Well, to be honest, I was a bit disappointed it didn't crack the egg. I thought it was going to make an omelet. And because
that would have
there's
really
always
blown
a
my
very
mind.
good, Well, it would be good because there's that adage, you can't make an omelet without breaking some eggs. And it didn't quite go that far. Maybe that's the next thing. Um, so yeah, and that is the thing that will be kind of crazy because when the egg breaks, suddenly everything gets a little bit wonky as far as the pressure that's there. You had a certain amount of pressure and boom, it's gone. How do you do that? So that would be the next delicate step. But there was so many other things in there showing, let's say, how all the movements have been integrated in together. It's kind of aware of its entire body and its motion. Like when you saw the squatting, in order to do that squat, you do have to get your center of gravity right, or you're going to fall over. And part of adjusting the center of gravity is you got to put your hands out there. And one of my questions was, is that something that Optimus kind of figured out on its own? Or was it kind of shown that or taught that in some way that when you do the squatting, this is what you want to do? I have a feeling it's almost like it kind of knows this is what it needs to do because it's noticing that its center of gravity is adjusting in a way it doesn't want to.
Wow.
And it kind of knows that this is what you have to do to get yourself back into balance. That's key for everything it's doing. All its movements, they really start to look human now. And if that's the kind of human movement they're talking about, then you can imagine FSD is also going to be very human as well. That's when they keep on saying it drives like a human, and now the bot starts walking and looking and acting like a human.
Do you think that it's possible that the bot is simply copying? We've been told the idea is that the bot ultimately will watch a human and then copy the human. Is that a possible way of training those movements?
I think so. I have a strong feeling that yes. And that was already shown by Google as an approach. I'm trying to remember when that paper came out. It came out in the late spring, I think,
Right.
the RT2 paper. And and definitely a lot of the FSD training has been done again by looking at many videos and deciding to do the training from that. So I would not be surprised that there's a certain amount of training, but I think also a certain amount of exploration that's going on, or curiosity. Something that's very interesting that the RSL lab here in ETH in Zurich came out with a paper talking about the way they train their bot is by giving it a certain amount of curiosity to explore its environment a bit more. And by doing that, they were able to get it to do more tasks much quicker with a much smaller training set. So it was doing things like figuring out how to open up a door and walk through it just by trial and error, and being kind of curious of what happens with its environment. And I would think you'd want to do the same thing with Optimus, is that you get it up to a certain level and then allow it to become a bit curious and how to do different tasks. So again, squatting, let it figure out how to squat, don't show it, and see if it falls on its butt, and have it do a bunch of times until it realizes, oh, I need to get my hands out there. Now, the interesting thing about the squatting video is the room it was in. It looked like it was, I don't know if it's just a room set up for Optimus or just a normal gym that they have somewhere in the Tesla headquarters, with all the exercise balls were there and some weights and a few other things. I don't know if that was coincidental or not, or if they're actually kind of helping to use those things to instruct Optimus what to do. So you have like one of those training balls underneath it. Learn to sit on this, learn to get your balance on that, like you would do with anyone in physical therapy.
That would be amazing if it could learn to just do sit-ups on that medicine ball or the balancing ball, and like really dial in a balance. I'm guessing like there's some additional connections it could make that would help it just kind of accelerate the balance thing. I want to ask about a touchy subject before we get into Matt's thoughts on the video. Handling wires. If it's got this level of detail with touch in the fingertips, do you think it could deal with wiring harness, or putting wires into a car? If the wires aren't rigid, if Tesla doesn't fully go that way, do you think it'd be able to see the wires and pick up the wires? That's been a sticky subject with Tesla, as they tried to over automate and realize that wires are really tough for robots to deal with.
I think so. I think that would be a possibility for sure. That again, Elon is saying that it should be able to thread a needle, and I don't know about you,
In about a year, yeah.
a needle is harder for for me than it is to do wiring. And of course, there's different kinds of wirings. If we're talking about, is it going to be ready to start, stripping wires and stuff like that and putting them in and screwing them down, that might be a little bit different than just saying, oh, taking a wire harness that already has a connector on it and being able to snap that connector in. So
Well,
sort
the
of
bigger-
like what they already showed that. Remember the unplugging? And that was
Yeah.
kind of an already loose cable, but I think now they could probably go in and unplug it.
Yeah, but the biggest challenge in wiring is not throwing it in the car. The biggest problem in wiring is actually building the harness, because that's by far the most expensive component, part of the wiring process.
Mhm.
And it seems to me that that would be, not a trivial, but that would be a very, straightforward task to train a bot to take a certain pre-colored wires and lay them in a harness and then bind them in a harness. It would seem to be, a natural job for a bot, right, Scott? What do you think?
Right. So that's more or less like just kind of stringing things. Yeah. Yeah. So I think that's you're
Be easier than
it
threading.
should be able, yeah, I think it would be able to do that because the wires are kind of bulky and not fine at that point, and it's just a methodology of what's the best way to take the wires and bring them through the nest that you're building.
Right. So
And once that's figured out, you just kind of follow that procedure.
yeah, the way harnesses are built today is, it's on boards that rotate around a center, and then each workstation puts a particular wire in a particular route on that harness, which is on a board, and then at the end they bind that together. That's kind of a simplistic picture of how it's done, and it seems to me that would be, it doesn't lend itself to automation because of the finicky business of putting the wires in a particular place. But I mean, it sounds like that's something that the bot, this bot seems to directionally towards doing, and that would be a huge win. I mean,
and I would not be surprised if that was some of the decisions on what to do with Optimus and the improvement to be able to accomplish a task like that.
right.
Yeah. And now, as far as other tasks, I saw today that Alexandra was, saying, "Oh, if it can only, iron my clothes and fold my laundry now." And I'm like, "Yeah, I think you're going to have your wish."
Yeah.
It seems to me that it has that potential capability given the new dexterity that we just saw and the sensors that they have in the hands.
Might be able to put it in the seat factory that Tesla has. We know that Tesla does struggle at times to hire as many people as they want for the boring, tedious, and stressful on the body jobs that they have, particularly at Gigafactory Nevada. My opinion, I think they're on the right track to having something that's going to be useful for them. What did you think of the video, Matt?
Yeah, it was very impressive. The end was a fun little Easter egg too with the dancing. Although I would say that's maybe not the most impressive thing. It's fairly easy to program those types of movements. Breakdancing would blow my mind. Yeah, if they can start spinning on one. I kind of doubt they're going to have the level of power needed to do some of those sorts of moves. So maybe we don't see that. But yeah, I mean, I think the overall kind of aesthetic improvements and the fact that they're using the Tesla actuators, I think was really impressive. The thing that stuck out to me was that they got a 10 kilogram weight reduction, or I think diet, as Scott coined it, which was pretty impressive. So I think that bodes well for cost savings. But I was also curious. I mean, that struck me as kind of a lot, and I was trying to figure out where they would have stripped 10 kilograms from. So I'm curious, Scott or Larry, do you have any kind of insight on where they could have found that type of
Matt, that was
savings?
exactly the question I was going to ask Scott, so I have no clue.
Okay. Well, this is something I discussed a little bit with Hans. He speculated, his guess was kind of similar to mine. When he looked at the lower leg, it looked like it's made out of injection molded plastic now. It's just a question of which would be the one that would give it kind of the strength and rigidity that you need. So I'm like wavering on whether that's fully plastic or whether that is somehow like coated aluminum. But I mean, they don't like making aluminum parts and then having to coat them or paint them. That's an additional step that they would like to avoid. So my only concern is like the bearing surfaces that you would have, whether, you know, some sort of plastic part would be able to survive that. But if they're able to actually get a durable plastic that allows them to mount the actuators in there the way they have, that's not going to wear out. I'm not that concerned about rigidity, because they even pointed out they don't care about rigidity in the AI Day 2 video, because they can adapt. That's why they have eyes and sensors and everything else. So they don't have to make it super, super stiff. There's no need for that. They just need to make sure that where the bearing surfaces are, they're not going to fracture or wear out. But I've been trying to reach out to a few people, and they think it could actually be made out of plastic, especially if the topology of the shape is optimized to reduce any sort of fracturing on there. And you know, they know how to optimize these things without a doubt. So that's where you get a lot of weight savings. You get a lot of cost savings and product and manufacturability savings right there, a lot. The other thing is they may have taken a little bit out of the pelvis, because the pelvis used to have what I called a pretty big pelvic girdle there. It looks to be about half the size now. And also the actuators seem like they've gone on a diet. They're lighter and tighter, as Elon has said. So I think overall, you know, you know, Sandy keeps on telling the story about he tells the engineers, you know, 1 gram a day or something like that when they're working on a vehicle. You know, if you just remove 1 gram a day, and eventually that adds up. And that's what they may have done, is they've gone through and they've reduced so much in many different places that they've been able to add more functionality while reducing the overall weight of the package, and probably made it way more manufacturable.
Is it possible they took mass out of the bones of it? Maybe they could have thinned out some of the tubes.
They could have.
Is it also possible, like some of the rods that are used to drive, could they have switched that from a metal to like a?
What about magnesium?
Okay.
That's always a possibility too. So you could use magnesium. I think the drive units, you'd still want to be metal, because you want to make sure those don't flex or on you too much. So you need stiffness there, but the actual bones themselves, I don't think they need to be that that rigid. And you could make them lighter, especially if you're able to make them hollow in some way. This is the thing, is that they shock us on how they're able to optimize a design when they get ready to do that.
Yeah.
And they've certainly shown that there's a lot of optimization. And you know what? I bet they'll tell you they're not even done. They probably already said, yeah, we've already got ideas for generation 3.
You know,
But
I was thinking magnesium because there's not a heck of a lot of metal necessary. And
yeah,
you know, you're getting such a huge increase in strength for a given weight.
and reducing weight, and it's a little bit more expensive than aluminum, but not that much.
Right.
It's not like going to titanium or anything silly like that.
Right.
So again, it's not like it blows your budget as far as the manufacturing cost.
But it could be an alloy, you know. I mean, they're so brilliant in metals, so maybe they've you know, spent a little bit of money on the alloy, because the weight saving is very dramatic, and I couldn't figure it out.
Are the actuators they're using, the drive units, are those necessarily bound to like some kind of limitation, maybe like the amount of current they can run through it? You know, what are the limits there? How much faster do you think this could get? Like, not just with the movement on the walking side, and we've seen an improvement in the foot, which we'll get into in a second, but just the movement of the limbs and the being able to quickly do things.
I think they can definitely use the power if they need it. They just probably don't want to, because you'd like to get an 8-hour battery life out of it. So they're trying to minimize everything to about 500 watts maximum when moving.
Are they also managing temperature in that too?
Well, in the battery module, they are. So, and I think that's being done just with a fan. I don't think they're doing liquid cooling or anything like that. So if they're only going up to 500 watts, it's probably not going to be that bad for cooling as far as the batteries overheating or anything like that. So they can be air cooled. You know, the other thing is you know, humans have developed a walking gait in order to conserve energy. So what we've just seen is it's 30% faster because it's got a better walking gait, not because it's consuming 30% more power. So as they improve that gait, there's going to be the energy savings right there. You won't need to have a whole lot of power. And part of that trick was what they've been doing with the foot. So they have a proper stride right now. You can see that the foot goes down with a heel strike, it flattens out, and then you see the toe off, where the toe box is coming up there. Now, the one thing I want to make clear is that in it, it says it's an articulated foot or toe. That does not mean there's an actuator in there. Okay, so they are not putting a motor in there to do it. They have some sort of compliance mechanism that's absorbing the energy and then just springing it right back, which is what we do. You know, basically, runners do that. Is you're able to absorb a little bit of energy in your ligaments and give that back into your motion. Now, they've also added the sensors, and that's very, very important. So they have the torque and pressure sensors on the feet, so they have an idea of how the foot is doing a strike in order to optimize the movements. So it's a combination of adding sensors to the feet and sensors to the hands that are giving it a whole new level of capability.
What are your thoughts here, Larry?
Well, you know, this is so the mechanics of walking and the energy spent are, you know, way over my pay grade. What interests me is the batteries and the wattage of the batteries, the storage capacity of the batteries used. And also, do they have the slow voltage, high voltage duality as the car has, or is one set of batteries supplying all the activity? And what is the, you know, what is the voltage being used by the motors in the bot? I have no idea about all of that. It's a question for Scott.
We might have lost Scott for a second here. I'm amazed if it all works on 500 watts. That's pretty amazing to me. If that includes a computer, I guess the FSD computer isn't that much. It's
Now, the FSD computer is an amazing, it's an amazing device. It draws very low, and remember they're only using, I think, 1/2. As I recall it. You know, I questioned that a lot. I thought they would need a lot more compute than half, you know, just the 1/2 of the board or the one chip.
Yeah.
But obviously it's to conserve power. Oh, there you go.
Okay, am I back?
Yes,
you are.
Okay, I was hearing the whole conversation, but for some reason I couldn't comment. So, yes, as far as the batteries go, if they have not changed anything since the AI Day 2, they are using 140 2170s and strings of, I think, 10 or 14, or is it 14? Maybe 10 strings of 14, I think, which give them 52 volts nominal.
Gotcha.
And a battery pack with 2.3 kilowatt hours.
2.3 kilowatt hour. Wow.
Which should be.
Well, that's going to give them about 5 hours, right?
Yeah, if they're running at
maximum output. Yeah.
Yeah.
Yeah, right. They're saying 8 hours is what they expect.
Okay.
Yeah, maybe if it's walking, then it's around 5 hours, Larry. But
yeah.
And it has, like, I think 100-watt idle, something like that. And it might be less than that, because it depending upon what the FSD chip is doing, it may be able to go as low as 75. But I think they're talking about 100 watts idle, 250 normal activity, 500 when walking.
That's cool. I want to talk about wear and tear, Scott. When Matt and I were putting together our model for Tesla Bot, thinking about a machine working 24 hours a day or 21 hours a day, and in our model we only assume 2 shifts a day, so essentially like 15 hours a day, just to be conservative, you know, doing that for a full year, no breaks on Saturdays and Sundays or holidays, no sick days, no needing to pick the kids up from school or anything. My worry was, like, after a year, like, these things would be toast. I'd like maybe for you to provide some perspective on electric motors and electric drives that go into robots.
Oh yeah, electric motors, I mean, they'll just run and run and run and run. You don't have to worry much about that. It's usually all the other parts or components that might break down over time.
Right.
And of course, if you do proper preventive maintenance on things, they will last pretty well. And I think you might remember the story I told you about the first all-electric robot that ABB came out with in 1972, in which when they unveiled it, most of the CEOs that were there, or I guess they were called presidents at that time because the CEOs weren't really the top of the company. And there was like a local farmer that did grinding in his barn that saw an immediate application and bought the very first one. And it ran and ran and ran. And eventually ABB decided to buy it back from him, I think, like in around 1990, somewhere around there.
They want to put it in a museum, right, Scott?
They put it in the museum, and he didn't want to give it up, so they had to provide him a new one.
It was
And
still
so
working.
it was still working, and it was a grinding application, which is like one of the worst applications because it's such a dusty kind of application.
I'm curious, Scott, going back to your hypothesis around a plastic injection molded leg as part of a weight savings, even if that does have potentially a lower useful life than let's say an aluminum piece, it seems to me that the cost savings would be so significant, and the kind of ease of replacing that part would be pretty trivial. So I mean, could that also be another application that maybe you have some parts of the bot that wear out faster than others, but you just order a new leg, Tesla ships it very cheaply, and the bot itself could even replace the part in question? Is that a potential, could Tesla be doing that kind of life cycle analysis, or is the injection molded plastic strong enough that it would last just as long as the electric motors?
I agree. I mean, they're going to come up with a way to make sure that they can probably get 2 to 3 years out of those things before they need to be replaced. And there may be some simple preventive maintenance you can do of popping out a joint or replacing something, but I agree, it's not going to be a wholesale swap out of the entire bot. It's just going to be finding out which components are not surviving or not having the durability, and then re-engineering them to last a little bit longer. I was impressed with, I think, some of the changes that they made, because I was a little bit concerned that some parts of the bot may not function very well. And I love some of the subtle little changes they made on the wrist and the ankle and everything else that I think will enhance the durability overall. But you're right. I mean, if you think about it, it usually, when an industrial robot goes down on the line, it's a bit of a disaster, because you either have to go in and swap out parts really quickly, or you literally have to swap out the robot. And it's really hard to swap out a robot from the line. It's just a lot of effort. And you don't necessarily want to keep having a bunch of them in reserve. That's kind of expensive. So they do whatever they can to make sure the mean time between failure is really, really long, and a lot of preventive maintenance to make sure they know that they're not going to fail. With the Tesla bot, because it is so interchangeable, it will be very, very easy to go ahead, swap out that bot with another one. So they'll be able to go into, like, one of the things it has to do is they have to recharge all the time, right? So my argument has been, there's not a swappable battery pack. The Tesla bot is the swappable battery pack. You always have one that's charging, and you have like 8 or 9 that are operating. And when that one's done charging, it goes over, taps the shoulder in the one with the lowest charge state and says, okay, go get charged. And you do that. And you can see the same thing with preventive maintenance and everything else. So if you know that the bots really can't go 24/7, maybe they can only go 24/6 or something like that, well, then you just buy a few more bots to make sure you can keep the manufacturing going 24/7. And then part of the cost is just having the extra bots that can swap around.
Yeah, the bot can do a self-diagnosis. So I think they showed that in one of the videos where it's looking at its hands or something like that. So it can on a daily basis look at its parts and see what's deformed. It can order a replacement part, and probably a lot of the parts it can self-repair.
I heard Matt say, change its own leg, but I think that's going to be a little tricky. And, I think you don't want to do that, because you have to power down that particular section. You have to take it out of the circuit. So you have to have isolation of various parts of the circuit.
Yeah.
I think that's a little, that's getting, into
Good point.
Is it
If
really
it's not,
worth?
if it's electronic, if it's just the shell, it could replace the shell, right?
Well, but electronics run everywhere, because every single motor has to have, sensors as well as power and so on and so forth. So I think that may be taking a step too far, but it's a great idea. I mean, maybe, Tesla will go to that. I think it's probably unnecessary.
Yeah, the bot may not be able to fix itself, but certainly other bots can fix other bots.
Yeah. Yeah.
So we'll have a bot medic for sure.
Is it possible, Scott, as far as like controlling electricity, where you can you shut off electricity to a region?
I would think the controller might be able to do it depending on how the harnessing is. So they may just
Well,
have something, you unplug it first, or you just make
but
sure
you've
it's
got
kind
to
of shut
create a
down.
physical, you got to create a physical switch to do that. And that's just added expense. Why would you go to that added expense?
Yeah.
That's weight and expense for very little gain, actually.
Yeah, you're right. You could just turn it off complete, like full power
But who
down.
knows, Tesla do these things. So from Matt's mouth to, Tesla's ears.
Well,
I think you've convinced me, Larry. That I think the incremental gains don't make a lot of sense
Yeah.
unless there's some way it can be automated, like some amazing circuitry that can be isolated. But to me, that seems, even if they were to spend a lot of time innovating on that, I think the gains would be relatively small. When, to Scott's point, you can just have another bot do it, or it would be simple enough for a human to figure out too.
Yeah.
Well, Scott, I remember an X Spaces we did after AI Day 2, and I think Larry actually joined us, and we were talking about this. We think that the low-hanging fruit is using Tesla Bot in the factory. Keep it simple. You can limit its environment. If you need to or want to, you can limit human interaction with the space it's in. So you don't have to have like a million different edge cases to solve. So it's possible maybe they can have a useful bot before they fully get there on autonomy. I'm curious what you think on that, but also I've been touting that I thought this bot would get 4 times faster, 4 times more dexterous in a year, versus what we saw on the stage in September 22. I think that's largely held. It's definitely much faster now walking. It's doing much more complex movements. I think the team in September 22 was worried it might fall over. They had a version of it they trotted out on a stand or whatever. And I think it's like maybe the first time they had it and not on a harness or something. What are your thoughts there, Scott?
It's definitely improved a lot. I mean, it's hard to say whether it's 4 times, Bradford, because 4 times 0 is 0, so it's almost like infinite improvement from what we saw. But still, the improvement is quite a bit, and that it's very close to human capable. I think there's going to be really rare situations where, let's say, most operations on the factory floor, it's not a sprint, it's a marathon. And while it's possible for a human to do it faster, the human cannot do it sustained.
Yeah.
In fact, a lot of times they are told, you're making everyone else look bad, you need to slow down. And it's not so much because it's the unions and you have to slow down. The reality is, if you come in there and think you can put in 8-hour days like that and do it for a career, you're not going to. You're going to injure yourself and hurt yourself. So in many cases, you do need to pace yourself. And I've known a lot of workers that have been kind of told that by the older workers and say, hey, when you get my age, your bones are going to hurt because you were really working too hard. So right now, I think the bot is able to kind of keep up with what would be the typical sort of rate that you would see on the line. And it can then only accelerate from there. So in a lot of those models where we've talked about going from being just a, maybe half of a human to being 1 human, and then maybe 1.5, we're starting to see that possibility is there. So when Matt starts looking at his numbers, he can start incorporating that in there.
Back in September 22, I was also cautioning people against a butler type bot that does your laundry and all that, because that's a much harder problem to solve, and dealing with uneven sidewalks and landscape and stuff around the house and stairs and all that. And I feel like this was Larry's reservation. What are you feeling now about, even though I don't think Tesla should go there yet, Larry, what are you thinking about the potential of a bot in the homes, or laundry, etc., all the crazy stuff?
Well, I'm 77 years of age, so I would, dearly love a bot in the house right now. Can't imagine what it's going to be like in 10 years' time.
Mhm.
So yeah, I mean, that would be great. But I think that it's clear that the low-hanging fruit is in repetitive, high value add, factory type work. I'm very excited about the concept now, which was foreign to me, of a bot doing really complex, very, very finicky electronic type work, because that's the work that we have, surrendered to the, and in fact, a whole lot of production work we've surrendered to the Far East, to third and fourth world and even second world. And I would love to see that return to the United States. I'd like to see us get much more active in manufacturing things. So that's the true high added value. But there's no doubt that in the long term, a commercial bot that's manufactured at scale and that's priced accordingly could ultimately become incredibly valuable to our human, day-to-day existence, particularly when we get people who really need help physically, as opposed, and possibly even, intellectually and mentally. So I think we're on a fantastic journey here. I think it's a journey that was necessary to align with, this move towards AGI, or at least improving the relatively brainless AI we have today. I call it brainless because it's, LLMs are simply, word association. But and we can have that argument on a separate channel. But yeah, I'm pretty excited. I think that this is, extraordinary progress. I think Scott has kind of has kept us abreast of where we are on the progress scale. And I think they're constantly lapping him, not lapping him, but certainly keeping up with his, prognostication. So it's pretty exciting.
Yeah, I was very impressed with what we saw recently. Matt, go ahead.
I think maybe the thing we haven't touched on too much yet is on the training side. And one of the things I'm trying to kind of wrap my head around is all the different tasks that you might want to do. We talked about folding laundry several times, making an omelet. There are innumerable different, preferences of how much salt somebody likes, or, what, how many eggs, just like how you like your laundry folded. So I'm wondering, how do you kind of handle that level of differentiation with, when I'm thinking about what Tesla said about training on FSD V12, for example, where you've got essentially zero insights until you had, was it 1 million video clips, like that? Just so you need huge amounts of data to get to the point where you're getting things useful. So to me, it seems like it may be a different type of problem, and maybe I'm wrong here. This is where maybe it's helpful to have a James Dalma or someone like that really attuned to the software side. But I guess, Larry, you might have some insights too of just how do you solve that problem of.
Well, it's kind of, I think the answer, Matt, is something like monkey say, monkey do. I mean, you have the bot watch you. You let the bot try, you correct the bot, and so there's this conversation between you and the bot. I think that would be, that would be the conceptual understanding of how to do it. So the idea is to train the bot through the bot seeing your actions and identifying its capability to your actions. Now, whether that's within reach or not, I don't know. It wouldn't shock me to see that happen. The training in the car is done by the car seeing and the car doing wrong and doing right, and then the analysis being done accordingly. Whether you can project that to what the human is seen to be doing or not, it seems potentially possible. Scott, what do you think?
Yeah, I agree that there's going to be more and more of the training, which we want to make sure is done from either video or watching some sort of human interaction. And there's going to be a little bit of telerobotic in that. So I think it's always going to be a combination of all those things. And at some point, also a lot of simulation. So you'll be able to simulate many, many different kind of activities and use that to train the bot. And then eventually it's just going to be the robot using its curiosity to start understanding its environment and then picking up those kind of details as you go along.
Yeah, perhaps
don't
you'll
you
be
also
given
need-
a pair of cameras to wear when you're actually doing the training.
Yeah.
That's the video it uses to start.
Yes. They already showed something like that where they had an operator wearing virtually the same headset that Optimus would have to have the same
Gotcha.
point of views. But the thing about that training, which was interesting at the time, the operator was moving their head, but Optimus couldn't do it, which might be why they decided, we think we need to put some motion in the head as well.
Yeah, that I commented at the time that that the notion of keeping the head not, motionless was problematic in many ways. So I'm very pleased they addressed that. In fact, that was the first thing I thought when I saw it. I should have mentioned that earlier.
So this brings up the question of sensors and latency. They've added quite a bit of sensors, and with the hand or the fingertips, there's like this whole heat map to it. We'll get to this question, but encourage people to check out our Tesla bot valuation that we have on Rebellionaire. Scott's done a ton of videos on Tesla bot with Dr. Know-It-All and Tesla Herbert, Brighter with Herbert. Larry's got a regular spot with Randy Kirk, and just did a great video about 48 volt. I do want to follow up with you, Larry, about that. But I want to get to latency before we go.
And Bradford, sorry to interrupt. Also with Bright, I'm on, with Brighter with Herbert 3 times a week as well.
I'll have to check that out. Scott, what do you think about adding all these sensors and latency?
Yeah, I'm not worried about the latency. And if anything, it makes the robot more dexterous and able to do more things much better because it's getting better information a lot quicker. And as we saw earlier, the torque control video, there was no latency in that.
Right.
It's able to respond really quickly. So, and they're probably using the same kind of communication that they're using in the Cybertruck, the gigabit. So it's probably getting the data more than quick enough.
Sounds like, I guess it can ignore sensors in certain times, so it doesn't have to be a deal where more sensors slows them down. I'm really excited about Tesla bot. We're very impressed with the progress they made. So I think various forms of training are going to help Tesla get to this point where they're truly end to end. So apparently they're not quite there yet, or they're struggling with that, and it's a really big problem for them to solve. But I trust that they'll get there.
Very excited to see this. This is a huge sleeper in the valuation of Tesla. It's not something you can quantify with any degree of accuracy, but that it is enormous, there's no doubt in my mind.
Matt and I try to quantify it. We show our assumptions in our Tesla bot video. We will be nowhere close to actuality, but I think we tried to show like how big it can get. Our valuation with our assumptions, which do have some conservative assumptions in there, some assumptions we think are realistic too, have it at $3,400 a share today in value.
It's as good a guess as any.
Not investment advice. Go ahead, Matt.
Yeah, no, you're right. I mean, the valuation nerd in me has been taught that you can at least take a stab at valuing anything. So, I think the best you can do is try to frame out what you think the opportunity is, and of course you'll be off on almost all of your assumptions probably. But I think what we all are seeing is just the magnitude of this opportunity. I mean, the TAM, as Elon has talked about, is the global labor market. And if that doesn't get you excited, then I don't know what will. One thought I maybe want to, I know we need to wrap, but one thought I had just on the training side is, it seems to me that it would be highly valuable to have some audio input as well, so that you can be saying, oh, no, not just like watch me repeat this step, but it would be a lot quicker to kind of troubleshoot some of these things if you can say, oh no, you need to tighten that bolt a little bit more, or no, this cup goes up on the next shelf up higher. Actually, that type of feedback seems like it would be really hard to implement, and maybe that's on a next gen version of the bot. But to me, it seems like in the long run, they'll need to have some kind of audio component to the not only training, but also just to the kind of, local course correction for instructions.
You can have other forms of vision too, infrared, ultraviolet, whatever would be helpful. Scott, closing thoughts?
Yeah, just on the audio, of course, there's a lot you can learn just by listening to machines and everything else in the factory, that from the audio, that, well, something's going right or wrong. It has nothing to do with language, but that's another important component. But yeah, I think my final thought was, it sort of resolves that conundrum we had back in May when Elon said something about in November they'll have the next generation, they'll have the Tesla design actuators, and we're like, well, wait a minute, we thought they already had that. What was that all about? And it's because they clearly were redesigning the whole thing. And the reason why they were not producing the number of bots as we were expecting is there's no reason to make 1,000 bots that are not what you want the final version to be. And so they were holding back on the production until they got it refined. And that's why Randy and I have been so off in our numbers on like what the numbers are going to be by the end of this year, to say that, there should be like, I was saying maybe around 500, maybe 1,000. And it's just like, no, they finally got the design. So we might be off by like a month or two, because now they've got it to the point that if they want to crank it up, they could like go really quickly. But again, the question is, do they right now feel like they need to mass produce 500 of these or 1,000? But they've got the design locked down that when they're ready to, they'll be able to do it.
I think they're a way away from that yet, Scott. I don't want to put too much of a damper, but the nature of design is that there's this curve, and I don't know where they think they are on this curve. So I would be a little bit more cautious about, they got it locked down now. I think they're a way away from that. That would be my guess. But, I mean, the rate of progress has been quite staggering.
It's a lot. It's a lot. And it explains why the other one was definitely not the one that they wanted to mass produce.
Yeah.
This is the one that they're probably ready to really give it a good test drive. And then once they do the shakedown on that, decide, are we going to be ready to go? Because that's sort of how the Cybertruck was. We saw a few of them are out there. They have the test mules that are going for a while. And when are they going to get the production ready? And then once they figure that out and get the refinement, then they're going to be much, much closer to it. So I definitely agree. And I think the cost of producing this is going to be a lot less than we thought before. The main reason why I'm, let's say, more bullish on them getting ready to do it is the fact that they've started to do the branding on the bot. This is the first time they actually threw the logo on the bot. It wasn't there before. And that usually says that you're getting close to what you think is a usable design. Now, it doesn't mean that they are not going to have designs after this. They're trying to figure out, when do we finally have something that we think will be able to do useful work in the factory? And maybe it's still a version 0.9, but a 0.9 can be pretty useful for a while and you get a lot of data on it. And the question is, what's the amount of data? Do you need a data with 100 bots, 1,000 bots, or 10,000 bots? And that's the question that we can't answer. That's really Tesla is the one that knows how many they think is going to be enough for that.
Maybe they'll make more bots this go around though, and continue the exponential rate of growth. I'm curious, like how much faster it gets as a walker. Being able to do this toe off, provided it has a spring back too, and just what we're going to see like a year from now. I think Tesla spoiled us with so many looks at the Tesla bot in the last year. I wouldn't expect to see an update every 4 months or so. Part of the reason Tesla does this is for recruiting purposes, to inspire all-star roboticists and others to join them. But I'm very optimistic, and really appreciate your thoughts, Scott, as you're out and about in Switzerland and doing that. And thank you, Larry, for joining us. And I'll say bye for now.
A complete list of all recommendations will be provided if requested for the preceding period of not less than 1 year. It should not be assumed that recommendations made in the future will be profitable or will equal the performance of the securities in this list.